What's up, everybody? How are you doing? Today, we're continuing our discussion on chemical reaction. This is chapter 4. Now, last time we talked about how we characterize reactions, the different types of reactions, and not only that, but we talked about how to predict the products of reactions based on what type of reactions they are. So when we predicted these products, one of the things that you realized was that the reactions were not balanced. So in this video, we're balancing our reactions, right? Now, balancing can be fun, but can also be frustrating at times. The good thing about balancing is that you can always check whether or not you got it right, and I'll show you why in a minute. So let's get started. So, balancing equations. So if we look at this equation right here, remember chemical equations have reactants, they have products, and they have an arrow that shows you that, for example, this one plus this one makes this one. And if you remember correctly our types of reactions, you'll know that this is a combination reaction. That's right. One thing plus another give you one compound. It's a combination reactions. And this we know, right? It's hydrogen combining with water to give hydrogen combining with oxygen to give you H2O, which is water. Now, we know the type of reaction this is, and we know what is combining, and we know how to predict the products of this. But one thing that you'll notice is this. You have two hydrogens here, you have two hydrogens here. That's okay. But look at this. You have two oxygens here, and you have only one oxygen here. So this is not balanced, and it needs to be balanced. The number of atoms on one side has to be equal to the number of the atoms on another. So when we look at a chemical reaction, kind of a reminder, a chemical reaction is going to show you the molar quantity of reactants. What does that mean? It means that, for example, here it's telling you that 1 mole of hydrogen plus 1 mole of oxygen gives you 1 mole of H2O. Now, this is not balanced, but it's expressed in moles, okay? So we're going to have moles of reactants on this side and then moles of products on this side. Now, again, the moles need to be equal and the number of the atoms need to be equal. And not only that, the mass needs to be equal. So the mass of atoms on this side needs to be equal to the mass of atoms on this side. Now, if you remember correctly, if you go back to the periodic table, you see that hydrogen has 2 as mass, oxygen has 16. So this is going to be 2 grams plus 16 times 2, because this is 2, is 32 grams of oxygen, right? But here you have 2 hydrogens, so it's 2 grams plus 1 oxygen, which is 18 grams. So this is not equal. These two are not equal. So they are not equal because they are not balanced. They are violating what we call the law of conservation of mass. What does it say? The law of conservation of mass is saying that matter cannot be either gained or lost in the process of chemical reaction. So in the process of chemical reaction, you cannot start with 34 and end up with 20 grams. We are violating a rule. So we balance our equations, we're going to balance our reactions, our chemical reactions, to make sure that you have the same number of atoms on either side, so that we can preserve the law of conservation of mass. Matter is not created or destroyed in a process of a chemical reaction. That is the idea behind balancing. We have to balance because of that. Always. All right, so if somebody gives you an equation like this is another example. HgO gives you Hg plus O2. By the way, what type of reaction is this? Think about it. Two things start together and then they open up. It's not a combination reaction, it's a decomposition reaction, because we breaking this into two parts. It's a decomposition reaction. Now, as you can see here, you have one Hg. Hg is mercury. One Hg, one Hg. But you have one oxygen here, then you have two oxygen atoms here. So this is not balanced either. So to balance this, look at what we did. We put 2 in front here, and then we put 2 in front. What does that make it? It makes it that we have 2 Hg atoms and 2 oxygen atoms here. And then here you have 2 Hg atoms and 2 oxygen atoms, and it is balanced. So we balance by adding numbers in front of our chemicals. And these numbers, we call them coefficients. We put them in front of our chemicals. They can't be down, right? So if I ask you to balance H2 plus O2 is equal to H2O, you can, so if you look at this, like we already said, the law of conservation of mass is not obeyed because it's not balanced. But you can never balance this by putting a 2 at the bottom. You cannot change the content and then put a 2 here, because you will have a different chemical, right? H2 is different from H2O2. H2O2 is poison, and H2O is water. So H2O, you don't change the chemical. You don't put a number at the bottom. You put it at the front. You never change the subscripts. Okay? So how do you balance then? Let's go through the steps, and there are many different tips and tricks of balancing, and different teachers will teach you different things, and I've taught this class many times, and this method that I'm going to show you has been the easiest way to balance equations. So make sure that you follow and take notes. All right, so here you have, so this is, I'm going to show you the steps that I go through. Okay, so you start with looking at your equation, and you see that your equation is not balanced. Okay, so I'm going to start by laying down my atoms on either side. So I'm going to draw a line for the reactants and the products, and then I'm going to lay down my atoms. All right, this is H, this is O. These are my atoms, right? So that's step 1. Step 2, write down the number of atoms. For hydrogen, I have 2. For oxygen, I have 2 on this side. And then for hydrogen, I have 2. For oxygen, I have 1. That's step 2. Write down the number of atoms. Now, step 3 is we're going to look at it and see, okay, which one is balanced, which one is not balanced. So here we start with from the top. Hydrogen, 2 on this side, 2 on this side, is balanced. Okay, that's good. Then look at this. Oxygen is 2 here, oxygen is 1 here. Then you're like, okay, what do I do to make them equal? If you have 2 on this side and 1 on this side, what do? You multiply by 2 on the side that has 1 so that you get 2, right? So what does that tell you? It tells you that you're going to put 2 in front of the chemical that has oxygen, and then whenever you put a number here, remember this is called a coefficient, you draw a line, another line, and then we write down the new number of atoms. So the new numbers for hydrogen is 4, for oxygen is 2. All right, so we just finished balancing oxygen. Now, is our reaction balanced? No. Why? Because you have 4 hydrogens here, you have 2 hydrogens here, but that's okay. You still decide. If we have 4 on this side and then we have 2 on this side, what would make them equal? Well, you multiply this side by 2. So that means that wherever you have hydrogen, you put 2 in front of it. And then you draw a line here. You write down the new number of moles. Here is 4. Here is still 2. And look at that. You have 4 and 2 atoms here, 4 and 2 atoms here, and it is balanced. So we just balanced our equation very easily by following these rules. And just to show you how easy it is, we're going to have another example. N2 plus H2 is equal to NH3. This is ammonia. Now, is this reaction balanced? No, because you have nitrogen is 2 here, nitrogen is 1. Hydrogen is 2 here, hydrogen is 3. So none of these are balanced. So again, step 1, you draw a line on your reactants and product. You write down the list of your chemicals in the same order, the list of your atoms in the same order. That's step 1. Step 2, write down the numbers of atoms. It's 2 for nitrogen, 2 for hydrogen. 1 for nitrogen here, 3 for hydrogen here. All right, that is step 2. Now step 3 is we're going to balance. So you have 2 here, you have 1 here. What does that tell you? It tells you that you need to multiply this side by 2 so that you can balance it. So let's just do that. We put 2 in front of NH3 so that we can balance it. So, and then again, whenever you put a number here, you draw a line to write down the new number of atoms. So look at this. N is 2, but look at hydrogen. Hydrogen became how many atoms? A lot of students miss this. You have 3 hydrogens here, but you have 2 that multiplies with it. So you have 6 atoms of hydrogen. All right, so are we done? No, we are not, because you have 2 here, that's nitrogen, but for hydrogen, you have 6 here, and then you have 2. Well, if you have 6 on this side and 2 on this side, what can we do to make them equal? It's easy, right? You multiply by 3 on this side. 2 times 3 is 6, right? So you multiply by 3 where you have hydrogen. So you put 3 in front of hydrogen. You draw a line here. So nitrogen is 2, hydrogen is 6, and it is balanced, right? Nitrogen and hydrogen are easily balanced. Okay. All right. So that is the step-by-step process that you follow. Now it can get tricky. It can get tricky because we've so far looked at simple, easy equations, but let's take it just a little bit. Let's step it up a little bit. Okay. All right. Look at this one, aluminum and chlorine, and then aluminum, chlorine. And you can pause this if you want to try it by yourself, but there is a little complication that you might get into, and I'll show you how to get rid of it. So step 1, you draw a line so that you can draw a line here for the reactants and then for the products. And then step 2, write down the number of atoms. Aluminum is 1, chlorine is 2. On this side, aluminum is 1, chlorine is 3. So look at this. Step 3, balance. Okay, let's balance. So aluminum balanced? Aluminum is balanced because it's 1 1 here. But look at chlorine. Chlorine is 2 here, chlorine is 3 here. It's not balanced. And not only is it not balanced, what are you going to multiply by 2 to make 3? There's nothing you can do, right? There's no whole number you can do that. And then what are you going to multiply by 3 to make it 2? There's nothing you can do about that, right? These are kind of mismatched. Remember, here we had 3 and 6. Here we had like 4 and 2 or something like that. But here you have 2 and 3. You cannot multiply one to get the other. So what is the best way to balance this? Well, even though you can't multiply anything by 2 to get 3, but they have something in common, right? If you multiply 2 by 3, what do you get? You get 6. If you multiply 3 by 2, what do you get? You get 6. So we're going to do a cross multiplication. That's what I call it. Cross multiplication. Meaning that since there is no number that we can multiply by either of them, what we're going to do is we're multiplying 3 by 2 here, multiplying 2 by 3 here, so that we get, well, 6. So how are we going to do it? Wherever you have chlorine that has 2, we put 3 on it. And then wherever we have chlorine that has 3 here, we put 2 on it. But again, you put the coefficient in front of the whole chemical. And again, on both sides, we draw a line so that we can write down the new number of moles. So here for aluminum, we have 1. For chlorine, we just made 6, right? Because 3 times 2. For aluminum here, you have 2. For chlorine, we have 6. So we just balanced chlorine by multiplying by 2 here and then by 3 here. Cross multiplication. All right, that's good. But are we done? No, we are not. Why? Because you have aluminum just got messed up, right? Because you have 2 here, you have 1 here. But we know how to do that, right? If you have 2 here, you have 1 here, how do we balance it? You multiply by 2 on this side. So I'm going to put 2 in front of aluminum, draw a line, and look at that. I have 2 and 6, and I just balanced this equation. All right? So that is cross multiplication. It's a little kind of hiccup you get to when you don't know which number to multiply with, but then you do a cross multiplication. Okay? All right, now I'm going to give you, before I go to the next one, I'm going to give you homework. Not homework, this is going to be for the quiz actually. So for the quiz, I want you to do aluminum plus oxygen, and this gives you aluminum. You should know how to predict this, but I'm just gonna give it to you so that you can just balance it. All right, so this is quiz question 1. Right? So based on all of these other reactions that we just did, balance this equation as well. So that's quiz question number 1. Balance this equation. Okay? Now that we got that out of the way, let's go to other types of reaction. Now, what type of reaction is this? C2H2 plus O2 gives you CO2 plus H2O. What type of reaction is this? It is a combustion reaction. Because remember, a combustion reaction is a reaction that has carbon and hydrogen here. So any reaction that has carbon and hydrogen, it doesn't matter what the numbers are here. If you add oxygen and the spark or energy, it's going to give you CO2 plus H2O. This is a combustion reaction. Okay, so whenever I give you anything that has carbon, so anything, so I say CXHY, whenever I give you anything that has carbon in it, and then I add oxygen, it's always going to give you CO2 plus H2O. It doesn't matter what X is or Y is. So this is a combustion reaction. But our task today is we got to balance it. How do we balance it? Step 1. Draw a line for the reactants and the products, and then list your atoms, right? And I usually like to have oxygen at the bottom. No matter what, it's going to help you in some of the equations to have oxygen at the bottom. All right, so let's add atoms. So I have 2 here, 2 here, 2 here. That's okay. And then here on this side I have 1 carbon, 2 hydrogens, and then look at oxygen. Oxygen is in both chemicals. It's very important to count it correctly. So here you have 2 oxygen plus 1 is 3 oxygen atoms. You have to count it correctly. All right, so let's start from the beginning. Carbon is 2 here, carbon is 1. All right, so what do we do to balance it? It's easy. You multiply this side by 2 so that carbon becomes 2. So carbon is 2 here, hydrogen is still 2, and then oxygen, look at oxygen. Oxygen was 2 here, right? Oxygen was 2, but it becomes what? It's going to become, no, it was 3, but it becomes 2 times 2 is 4 plus 1 is 5. So now you have 5. And then we run into the same problem, right? So we have carbon balance, hydrogen balance, but oxygen is not balanced. And not only is it not balanced, but it's a mismatch. There's nothing we can multiply by 2 to get 5. But it's okay. Why is it okay? It's because we know how to cross multiply. Even though there's nothing we can multiply by 2 to get 5, we're going to cross multiply, meaning that we're going to multiply by 2 on this side to get 10, and we multiply by 5 on this side. Cross multiply. But only where you have oxygen, right? You're going to only multiply where you have oxygen. It's very important. So where you have oxygen here, when you have oxygen as 2, we're going to multiply by 5. So I'm going to put 5 in front here, right? But then where we have oxygen on this side, we multiply by 2. But here's the kicker, guys. Pay attention. On this side, oxygen is in 2 locations. So we're going to multiply by 2 in 2 locations. So oxygen is on this side. Here is 2. 2 multiplied by 2 is 4. And then here, oxygen is on this side here. There is 1 here, multiplied by 2 is 2. Right? So I just multiplied this side by 2. And I multiplied both sides because we have oxygen on both sides. It's very important. And then when we can do that, we draw a line on both sides so that we can write down the new number of atoms. So carbon is still 2 here, hydrogen is still 2, oxygen now becomes 10. How about here? Carbon now is 4. Hydrogen is 4 because it's 2 times 2. And look at oxygen. Oxygen is 4 times 2 is 8, plus 2 is 10. So we just now balanced oxygen at the bottom. And that's okay. But look at the other ones. Here you have 4, 4, and then 2, 2. These are not balanced. We're almost there, guys. So if you have 2 here and then you have 4 here, what do? You multiply by 2 on this side. So where do we have carbon? Here. You multiply by 2. And then you draw a line. Carbon becomes 4, and hydrogen becomes 4, and then oxygen is still 10. And look at that. It is balanced. 4, 4, 10. 4, 4, 10, right? That's why I said, by the way, that balancing is easy, because you can always check your work. If you know how to count atoms, then you can always check whether or not it's balanced, because you can just count atoms. You can be like, okay, carbon is 2 times 2 is 4 carbons. Do I have 4 carbons here? Yes, I have 4 carbons. What about hydrogen? Hydrogen is 2 times 2 is 4 hydrogens. Do I have 4 hydrogens here? Yes, because it's 2 times 2 is 4 hydrogens. Okay, what about oxygen? 5 times 2 is 10 oxygens. Okay, do I have 10 oxygens here? Yes, I do, because I have 4 times 2 is 8 oxygens plus 2 oxygens is 10. So you can always double check your work. Double check whether or not you have balanced your reaction. Okay? All right, so if you know how to do this, you should basically know all the tips and tricks. So I'm going to give you another quiz question / practice question. So quiz question number 2 is C2H6. Okay, instead of C2H2, it's C2H6. So C2H6 plus O2, and also it always gives you CO2 plus H2O, but as you can see, this is not balanced. So use the techniques that we just used in this one. So the techniques, the step-by-step process, the cross multiplication and all that stuff, use it to balance this and make sure that it is balanced. Okay, it's very important. All right, so now that we have quiz question number 3, let's look at another example. Now you have aluminum plus sodium chloride is equal to aluminum chloride plus sodium. What type of reaction is this? Do you remember? That's right, it's a single replacement. Single replacement because you have one thing plus two things is equal to two things plus one thing, right? This aluminum is going to come in and replace Na. That is a single replacement, but that's not our job today. Our job today is balance it. Why? Because it's not balanced. It's almost balanced, right? Aluminum is the one that's not balanced, but we know the steps to follow. Step 1, draw a line here and then list our atoms: aluminum, NaCl, aluminum, NaCl. All right, that's step 1. Step 2, number of atoms. So 1, 1, 1 here. What about this one? 1, 1, 3. All right, so that's step 2. Step 3, balance. Okay, Al is balanced, 1, 1. Na balanced. But what about chlorine? Chlorine is 1 here, chlorine is 3 here. What does that tell us? We need to multiply by 3 where you have chlorine on this side. So how do we do that? You put a coefficient in front of NaCl, right? And then you draw a line so that you can write down the new number of atoms. So aluminum is still 1. Sodium is now 3. Chlorine is 3. All right, are we balanced? No, we are not balanced because now we just messed up sodium. We have 3 here, we have 1 here, but that's okay because what do? We're going to multiply. So you have 3 here, you have 1 here, you multiply this side by 3. So you go where you have Na, you put 3 in the front, you draw a line, and now you have aluminum, which is 1, sodium is 3, then chlorine is 3, and it is balanced. It's balanced. All right. How about something like this? First of all, what type of reaction is this? Well, it's 2 things plus 2 things. It's a double replacement reaction. All right, so again, even though it's a double replacement reaction, you still treat it the same way, right? Same steps. And again, this one, you have how many atoms? 1, 2, 3, 4, 5. 5 atoms, doesn't matter. Still the same steps. So don't be intimidated by many atoms. As long as, remember, you gotta follow the same order. So MgS, or they have to be the same order because remember we're comparing them, right? And Cl at the bottom. And again, sometimes I like to put oxygen at the bottom, but this time it's okay. It's not harm. It doesn't make a big difference. So step 1, draw a line. Step 2, count the atoms. So I feel like I want to move this. I wonder if I can do that. Okay. Yes, let me move this way. There you go. All right, so count the atoms. That's step 2. Magnesium is 1, sulfur is 1. How about oxygen? Oxygen is 4. How about aluminum? Aluminum is 1. How about chlorine? Chlorine is 3. All right. You know what? I actually want to put. No, it's okay. I just realized that I should have put oxygen at the bottom as well, because oxygen sometimes gives us a lot of problems. That's okay. That's okay. Let's continue this way. Magnesium is 1. Sulfur here. Okay, pay attention. How many atoms does sulfur have? If you have 3 outside the parentheses, it applies inside. So sulfur here has 3 atoms. Very important. And then look at this. How many atoms does oxygen have here? It's 3 times 4. Because you have 4 here and then the parenthesis is multiplied by 3. So you have 12 atoms of oxygen here. Right? So a lot of students actually miss questions in errors in just counting. Alright? So it's 12 oxygen. How many aluminum? 2. How many chlorine atoms? 2. All right. So again, this is many atoms. You have a lot of mismatches, but don't be intimidated. We're going to follow our tried and true method. Okay. What's our tried and true method? Start from the top. Magnesium. Magnesium has 1. We don't have to worry about that. What about sulfur? Sulfur has 1 on this side. It has 3 on this side. So how do we balance that? We're going to multiply by 3 on the side that has 1, right? And again, you put 3 in front of the whole thing, not just sulfur. So you put 3 here, and then after you put in 3, whenever you write down a new coefficient, you draw a line to write down the new number of atoms. So look at this. We just messed up magnesium. Magnesium now is 3. What about sulfur? Sulfur is 3 times 1 is 3. So sulfur is balanced, right? And then oxygen is 3 times 4 now. So oxygen is 12. Oh, it's balanced as well. Aluminum is still 1. Chlorine is still 3. All right. So now magnesium. So we after we do that, we step back and go back from the top. Are we balanced? No. Why? Magnesium is 3 here, magnesium is 1. How do we solve that? We're going to put 3, right? We're going to put 3 in front of magnesium, right? Draw a line so that we write down the new numbers, right? So it's 3 magnesium. What about sulfur? Sulfur is still 3. What about oxygen? Oxygen is still 12. What about aluminum? Aluminum is still 2. And then what about chlorine? Chlorine is 6. All right. Now we're getting somewhere. Okay, let's step back. Magnesium is 3, balanced. Sulfur is 3, balanced. Oxygen is 12, balanced. Aluminum, not quite. You have 1 here, you have 3 here. What does that tell you? No, you have 2 here. What does that tell you? It tells you that you need to, so you have 2 here, you have 1 here, so you're going to multiply by this side, you're going to multiply this side by 2. So you put 2 in front of aluminum, you draw a line so that you have magnesium is 3, sulfur is 3, oxygen is still 12, and look at this, aluminum is 2, and chlorine is 2 times 3, it's 6. And why am I happy about that? Because there's 6 here as well. So you have 3, 3, 3, 3, 12, 12, 2, 2, 6, 6. So we just balanced this. By following the simple steps that we laid out, we just balanced this 5-atom, 4-compound chemical reaction. That is a double replacement. So as long as you follow these steps, you're not going to have any problem. Okay? As long as you follow these steps, you're not going to have any problem. And in the end, you should be able to look at the coefficients that you have and use them to count what you have to make sure that you have the right balance. That's the beauty of balancing. Again, is because you can see, like, do I have aluminum, the same number of aluminum? Yes, because I have 2 here and then I have 2 here. What about oxygen? Oxygen, I have 12 here and then I have 12 here. So if you know how to count well, you should be able to double check whether or not your balancing is correct. Okay. All right. Now what I want to do is I want to give you a quiz question. So this quiz question is going to be a bit different because okay. Let's see. trying to make it interesting, but not. No, I'm trying to make it interesting, not boring, but also not too difficult. All right, so sodium sulfate plus aluminum hydroxide. So I want you to do for this one, I want you to do two things, right? So I'm not going to give you the products. So first of all, I'm going to give you a quick hint. What type of reaction is this? It's a double replacement. So you should know how a double replacement behaves. And from what you know about how a double replacement behaves, you're going to go ahead and give me the answers to this question, to this equation. It should be two things. And then after you give me the answers to this equation, you're going to balance it. So for this question, you're going to predict the products and balance. That's what you're going to give me for this one. Okay, and again, you should be able to do that based on what we know about double replacement reaction. And from there, you should give me two products that are well balanced. Okay, make sure that you use the cross rule, use the correct use of coefficients and things like that. And with the three quiz questions that I gave you, if you're able to do them really well and show your work, that should be enough for you to understand balancing very well. But that is enough for today. I'll see you in the next video. Bye bye.